Welcome back, Math 7. Today's lesson is a little bit of a reinforcement of lesson number 3, complex area calculation. So, as you may notice, circle, when it comes to calculation skill related to chapter 8, you need to understand two parts. One is circumference, which is the total distance around a circle. And number two is space that you can occupy inside of that circumference, which is area. So today we are not learning something new from our textbook. In fact, textbook section is exactly identical. If there's something that I focus, probably it will be page 286 of your textbook. Just for the heads up. We are gonna do two examples. One that I'm gonna do using how can I say, using just on-spot question, and another one I am going to go through textbook example. Both of them require drawing, so I want you to prepare any type of compass and ruler. So without further ado, let's go through what I mean by complex area question. In geometry, when you say complex geometry, that's basically any type of shape that is involved more than one object. So you're gonna see multiple circle situation. So have that in your mind. Or sometimes you need to deal with semicircle, little deformed circle. We're not doing any type of oval shape, so have that in your mind. Without further ado, let's get this started. So this is class example. Seems like it's a little distorted, so I'm going to adjust. That's a little better for my part. I'm going to draw two circles, but one of the drawing, and I'm going to draw some big scale. Should have thought of this object. Oh moly. Sorry, I'm just gonna draw side of the screen. There you go. Sorry about that. The space has some problem. Then I'm going to draw inner circle like that. So imagine this is a cross section of a pipe, like copper pipe, something like that. The question is asking, find out the area that is shaded. And calculate. And let's say here are two clues that is given. Diameter, let's say this was 12.6 meter. And I have entire radius that turned out to be 8 0.0 meter, something like that. So this is a good example of complex area calculation because I have two clues. One thing is diameter is given. I'm gonna put ds. The one represents smaller circle diameter. You can use any of the letter to be honest, A, B, C, those kind of thing, as long as it's lowercase or X, Y, Z. But I'm gonna use with subscript diameter of small circle, which is 12.6 meter. And I have radius of big circle, which is 8.0 meter. Now let's think about it. In order to find this shaded area, how can I find just this outer area that is shaded? Here's the thing. It is very case by case when it comes to complex area. But as you may know, I can find bigger circle area and I can find small circle. And if I subtract big circle area, which is the total area inside, by just small circle area, then we will get the shaded area, which is outer rim area that we can find. So we need to have a case-by-case design. Formula is exactly same. Each of these formula, we're gonna use pi r squared. So let's figure out bigger circle area first, then smaller circle, then we can find out the shaded area. So it's involved 2 to 3 steps. Before we getting into, as you may notice, radius plays a huge role. But I have diameter of smaller circle given to you, which means if I just divide it by 2, then you're gonna have smaller circle's radius. 12.6 divided by 2 is basically 6.3 meter. So that's a fancy way of saying that I can use 6.3 meter instead of the total 12.6 meter situation. So number one, my big circle area, pi r squared, that's my formula. So first step and second step, listing first step, formula second step is done. My third step is punching the number in. 3.14 times by bigger radius, which is 8.0 meter times by 8.0 meter. And we're gonna write down every single thing. We're not gonna round up any numbers yet. So 3.14 times by 8 times by 8, that is equal to 200.96 meters squared. That is my bigger circle area. Now, small circle area, same thing. 3.14 times by 6.3 meter, 6.3 meter. As you may notice, the only thing that differs in here is not the formula. It's just whatever number that should be punched in. So 3.14 times by 6.3 and 6.3 again. Then you will have 124.6266 meters squared. So now I have bigger circle area, smaller circle area. So I can just subtract these two numbers. 200.96 minus 124.6266 should be equal to 76.3334 meters squared. That is my shaded area, and we gotta round it up. Although I didn't say in the question, let's round it up to 2 decimal place. So that means decimal, whatever next. 76.33 square is my shaded area. That is how you solve complex example like the one that you see. It is really case by case. Next example. I'm gonna use textbook example. It is number 19 of extended question on page 286. In fact, if you don't mind, I am going to draw a diagram that is given. Although it's not pretty, but I have a semicircle, another semicircle. The shaded area is this area, and I have these two measurement information is given. Now let's talk about semicircle first. The word semi means half. So you can consider this as semicircle as half circle. So in terms of space, you can think that the space also become half because you can occupy only half of the circle space. So area change actually, if you guys remember, area is as pi r square. But if I modify this formula into semicircle situation, you better divide it by 2. So area of semicircle is basically equal to pi r square over 2. If you want to how can I say, modify this a little bit, it will look like this: pi times r divided by 2. That's basically what you can put in your calculator. Now let's think about this. We have to think about quite a lot in here because, as you may know, I have a full half circle, but I need to take another half circle area out. And you may notice that this 1, 2 empty space, whatever you see empty space or unshaded, or I don't know whether this word is actually the word, not shaded region, is basically means you gotta subtract. So what we can do is, from the total area, we can subtract first one and second one. But you may notice that first one and second one, the size is identical because can you see the diameter for the one half circle and then the diameter of another half circle? It is exact same, 4 and 4. So that means these two areas are identical. A lot of things happen, but let's do step by step. First step, write down some of the clue. Radius of bigger circle is given actually as 4 centimeter, because if you look at the entire half circle, semicircle, can you see 8 centimeters my total distance divided by 2 is 4? Or you already see that, oh, that's my center, 4 and 4. Now you may notice diameter of smaller circle is given as 4 centimeter. Whenever you see diameter for your area calculation, I said to divide it by 2 for your radius of the small circle, which is 4 divided by 2, 4 centimeter. Now, next goal, which is like second step, which is kind of done in here, pi r squared divided by 2. So this is your second step. Let's do substitution already. My total area before we subtract is basically pi r squared divided by 2. In fact, it's a bigger radius. So 3.14 times 4 centimeter times 4 centimeter divided by 2 is what you need to do. Take out your calculator. 3.14 times by 4 times by 4 divided by 2. You will have 25.12 centimeters square. That is my total semicircle situation. Now, A1, the empty one, we are going to try to find it, but that is equal to A2 because it's identical shape. It is also semicircle. So it's pi r squared divided by 2. But the number that you need to punch in is 3.14 times by the radius of a small circle was 2 centimeters. So 2 centimeter times by 2 centimeter divided by 2. And now that's a punch the number in situation. 3.14 times 2 divided by 2 is equal to 6.28 centimeters squared. That's what it is. Now, our final step, subtracting it and figure out the shaded area. Shaded area is equal to my total, 25.12 centimeters squared minus 6.28 centimeters squared, but we have two of the identical circle, 1 and 2. And that'll be my final answer. So, 25.12 minus 12.56 shaded area is 12.56 centimeters square. And that is today's lesson. It is not necessarily something new. It is advanced type of question. So your to-do list is give it a shot on page 286, 14, 15, 16, 20. Those 4 questions.